The dual-fuel engine utilizes a lean burn combustion process when operating on gas. Here, the gas is mixed with air before the intake valves during the air intake period. After the compression phase, the gas-air mixture is ignited by a small amount of liquid pilot fuel. This pilot fuel is pressurized and fed into the cylinders by a small common rail system. Combustion is fast, and after the working phase, the exhaust gas valves open and the cylinder is emptied of exhaust gases. The inlet air valves open when the exhaust gas valves close, and the process starts again. The dual-fuel engine is also equipped with a backup fuel system. This is a normal diesel process with camshaft-operated liquid fuel pumps. The pumps run in parallel with the process and work as a standby. Gas and pilot injection is not in use during liquid fuel operation. The liquid fuel operation process is the same as the conventional diesel process.
Most diesel fuel injectors use the same basic design, made from heat-treated alloy steel. The actual shape will vary according to the application. The injector assembly has several main parts. The nozzle assembly is made up of a needle and body. A pressure spring and spindle hold the needle on the seat in the nozzle body. A nozzle holder, sometimes called the injector body, may allow for mounting the injector on the engine and some method of adjusting the spring force applied to the needle valve. A cover keeps out dirt and water. The injection pump delivers fuel to the injector. The fuel passes through a drilling in the nozzle body to a chamber above where the needle valve seats in the nozzle assembly. As fuel pressure in the injector gallery rises, it acts on the tapered shoulder of the needle valve, increasing the pressure until it overcomes the force from the spring and lifts the needle valve from its seat. The highly pressurized fuel enters the engine at a high velocity in an atomized spray. As soon as delivery from the pump stops, pressure under the needle tapered shoulder drops, and the spring force pushes the needle down on the seat, cutting off the fuel supply to the engine. Some of the fuel is allowed to leak between the nozzle needle and the body to cool and lubricate the injector. This fuel is collected by the leak-off line and returned to the fuel tank for later use. There are two main types of injector nozzle, hole and pintle. Hole-type nozzles are commonly used in direct injection engines. They can be single-hole or multi-hole, and they operate at very high pressures, up to 200 atmospheres. They give a hard spray which is necessary to penetrate the highly compressed air. The fuel has a high velocity and good atomization, which is desirable in open combustion chamber engines. In pintle-type nozzles, a pin, or pintle, protrudes through a spray hole. The shape of the pintle determines the shape of the spray and the atomization of the spray pattern. Pintle nozzles open at lower pressures than hole-type nozzles. They're used in indirect injection engines, where the fuel has a comparatively short distance to travel and the air is not as compressed as in the main chamber.